Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we have another topic, that is transverse stationary waves in a straight string. Suppose if we have uh, a straight string and we fixed or we clamped this string into 2 points. We fixed it from this end and we fixed it from this end. So this system is placed in vacuum, means there is no air resistance. So this end is fixed at one point, this is fixed at another point. Okay, now I want to plug it. Okay, now I want to plug mean disturb. I want to disturb this string, so it will start vibration. So for example, if I plucked it, so it will start vibration. So it will be move up and down. Will move up and down. Okay. Now remember, the point where the amplitude is maximum, that is called antinode. The point where the amplitude is zero, that is called the node. So this point is a node. This point is a node. This is called antinode. Okay. Now this string will start vibration. So the amplitude of this wave and the amplitude of this wave is same. So if the amplitude is same, look at the amplitude. This amplitude and this amplitude is same, and look at here. This crust is flowing towards right, and this trough is flowing towards left. So the direction is opposite. If the direction is opposite, so this wave is called the stationary wave. So stationary wave can be defined as when the amplitudes are same and directions are opposite. So this is called stationary waves. Okay. Remember, if we talk about the progressive wave, so progressive wave is traveling from one point to another point, while progressive wave there is no energy transfer from one in stationary wave, there is no energy transfer from one point to another point. So here the energy is maintained or confined between these 2 points. So it means that the wave will goes and strike to this end, so it will be reflect back, and this wave goes and will strike at this point and will be get reflected. Due to the continuous reflection, the energy will be constant between these 2 points. Okay, remember, the point where amplitude is zero is called node, antinode, node, antinode, node. Okay, look at this. This is one cycle, and the distance covered in one cycle is called lambda. In the half cycle, it is lambda by 2, and another half, that is called lambda by 4. This is called 1/4. At 1/4, the distance is lambda by 4. So if someone asks you what is the distance between node and antinode, so you have to told him, you have to say, you have to tell him that the distance between the node and antinode is lambda by 4, and the distance between the two consecutive nodes is lambda by 2. The distance between the two consecutive nodes is lambda by 2, and the distance between node or antinode is lambda by 4. Okay, now I'm talking about case number 1. Okay, now talking about case number 1, let us consider we have a stretch string which is closed, which is clamped between the 2 points, and this is the middle point, means the half. If I plugged it at the middle, so there is only one loop will produced. So if there is only one loop is produced, this called antinode, this called node, this called node. Okay, now look at here. This is one node, this is another node. So the distance between the two nodes is equal to lambda by 2. So the distance between the two consecutive nodes is lambda by 2. So lambda from here will be equal to 2L. Lambda will be equal to 2L. Okay. Now the formula for the frequency is V by lambda, and putting the value of lambda here, which is 2L. So this is called the fundamental frequency or the first harmonic frequency. This is called the fundamental frequency or the first harmonic frequency, V by 2L. V by 2L is fundamental or first harmonic frequency. Okay. Now we know that the speed of transverse wave, so putting the value of speed of transverse wave here, so it will be 1 over 2L, and the speed of transverse wave is T into L divided by M. So it means that fundamental frequency depends upon the tension, the length of the medium, and the mass of the medium. Okay, these are the factors of the fundamental frequency. So this is the fundamental frequency. Fundamental frequency means the minimum frequency in stationary waves. First harmonic. Harmonic means loop. So there is only one loop. This is only one loop. So this is called the first harmonic frequency. So if there are two loops, second harmonic frequency. If there are three loops, third harmonic frequency, and so on. Okay. Now let us consider case number 2. In case number 2, we took the same string of length L. Now this is half and this is 1/4. Now we want to pluck at 1/4. So if I plucked it at 1/4, so I will observe there are two loops will produce in the string. So if there are two loops is produced in the string, so this is node, this is node. So the distance between the two consecutive nodes is lambda by 2, and this is node, this is node. So the distance between the consecutive nodes is lambda by 2. So from here to here lambda by 2, from here to here the distance is lambda by 2. So lambda by 2 plus lambda by 2. So took the LCM, so it will be equal to lambda plus lambda, so it will be 2 lambda, 2 will be cancelled, so L will be equal to lambda. So L will be equal to lambda. Okay. So length will be equal to lambda. So now the formula for the frequency is V by lambda. So lambda is here equal to L. So the formula for the frequency is V by L. Okay. The formula for the frequency is V by L. So this is called the first overtune frequency or the second harmonic frequency. So this is the first overtune. Overtune means integral multiple of fundamental. Overtune means the frequency in more than one loop is called overtune frequency, and there are two loops, so this is called the second harmonic frequency. Okay. If we compare this frequency with the other frequency, so look here, we can multiply 2 on both sides. So what we have, look, multiply 2 up and down, and V by 2L is equal to fundamental. So this frequency is double of fundamental. So it means that the first overtune frequency is double of the fundamental frequency. Okay. Now case number 3. Case number 3, we took the same string of length L. This is half, this is 1/4, this is 1/6. So now I'm going to pluck it at 1/6. So when we plucked at 1/6, so we will observe that there are three loops will produced. So when three loops are produced, so look at here, this is node, this is another node, this is another node, this is another node. So the distance between the two nodes is lambda by 2, lambda by 2, and lambda by 2. So the total distance is 3 lambda by 2. The total distance is 3 lambda by 2. Okay. Now lambda will be equal to 2L divided by 3. Lambda will be equal to 2L by 3. Okay. Now putting this equation in frequency, the equation for the frequency is V by lambda. Putting the value of lambda here, so it will be V by 2L by 3. So shift L by 3 up, so it will be 3 by 2L. Okay, this is called the second overtune frequency or the third harmonic frequency. Okay, what is the value of V? We know that the value of V is T into L divided by M under root. This is the value of V. Okay. Now this frequency is actually the second overtune frequency, or if we compare what is V by 2L, V by 2L is fundamental, so this frequency is triple of fundamental. Okay, it means second overtune frequency is triple of fundamental frequency. Okay, and likewise we can discuss more cases. So the first frequency is F0, the second is 2F0, the third is 3F0, the in another case the frequency will be 4F0, in another case the frequency will be 5F0. So at the last frequency will be NF0. What is F0? We know that F0 is V by 2L. And what is V? You know that V is the speed of transverse waves. So this is all about the transverse stationary waves in a straight string. If you have any question, you can ask in comment section. Okay, take care. Allah Hafiz.